VLSos here. This is a video lesson on log properties. What is a property? It is a generalization about numbers that is always true. For instance, a times b is equal to b times a. This is not a property of logarithms, this is a property of multiplication. No matter what your numbers, a and b, you can change the order and it will still evaluate to be the same thing. We can investigate whether numbers have properties by thinking of a property to test. We could test the log property. Is the log base x of y equal to log base y of x? And we don't know if this is true yet, so we can put a question mark above it. These two sides aren't going to be equal unless we can choose any values for x and y and have it always be true, that switching the log base and what you're taking log base of can be switched and it will evaluate to be the same. One way to test whether a property exists is to come up with an example. In this case, we can invent by putting or finding numbers or deciding upon numbers for x and y, such as, is the log base 5 of 25 equal to the log base 25 of 5? In other words, is this true? Can I switch the log base and what I'm taking the log of? Well, in order to see if this is true in this case, we're going to separate the sides and I'm going to convert each side into exponential form and then see if the sides compare. So I'm going to work one side at a time and I'm making an equation out of this so that I can move the log base 5 to the other side and get 25 by itself. How do I undo log base 5 with its inverse power base 5? So I've made each side the power whose base is 5. That will cancel out the log base 5, leaving the 25 on this side. And on the left side, I have 5 to the y. And I can think, what power of 5 is equal to 25? 5 squared is equal to 25, so in this case, y is equal to 2. Let's see what's going on the other side where we've switched the log base and what we're taking the log of. So I'm going to assign this to be a variable so that I can take the 25th power base of each side so that the log base 25 and the power base 25 cancel out, leaving the 5 left on the 5 on the left. And then I'm thinking, what is the power of 25 that will get 5? And that's not quite as mysterious as you might think at first, because 5 is equal to the square root of 25. And square rooting is the same thing as a half power. So in this case, x must be 1/2, because 1/2 power of 25 is the same thing as the square root of 25, and that's the other side. Now let's compare the two sides. If this property held, then this case of testing it should make these two sides evaluate the same. And they don't, because this is not a property of logarithms. We have determined that switching the log base and what you're taking the log of doesn't work. And this here, a test case to show that it's not working, is called a counterexample. We tried to discover a property of logarithms, and we discovered that logs do not behave this way. let's try this again. Here I have a candidate for a property of logs. Log base 10, this is common log, of b to the x. Is that equal to x times the log, common log, of b? This is a property of logarithms if I can choose any b and any x and have it always work. I can test that, or begin to, by choosing some values, such as the log of 100 squared, and seeing if that's equal to 2 times the log of 100. What's the relationship between the two sides of this property that we're testing? Notice that on one side, x is in the exponent position of what we're taking the log of, and on the other side, we have the x out in front multiplying the log. It's almost as if we're moving the exponent out in front. Can we do that? Well, let's see in this case. The strategy of seeing whether this is going to work, just like before, is to evaluate one side and then evaluate the other and compare. So to evaluate this left side, I'm going to make it equal to a variable. So it helps me to think by turning it into exponential form. In order to undo, I don't need to do that. I'm not going to undo the log because all I need to do is square this 100. This is log base 10 of 100 squared, or y is equal to log of 10,000. 100 squared is 100 times 100, or 10,000. Now I'm going to power base 10 both sides, so that the log base 10, this common log, cancels out, leaving the 10,000 on the right. And then I can think, what power of 10 is equal to 10,000? 10 times itself 4 times is equal to 10,000. So y must equal 4. Let's take a look at the other side. 2 times log base 10 of 100. If I think of this log of 100, then I could evaluate this with a calculator, or I could think, what power of 10 is equal to 100? 10 to the what is equal to 100? 2. So the log of 100 is 2. And in this case, I've evaluated log of 100, I multiply by the 2 out front, and we get 4. Let's compare. The two sides are the same value. It appears that this case of this property suggests that this property is working. One example, however, does not prove a rule. So we have to be careful. We tested a rule with one example and it worked. That doesn't automatically mean that this is a property of logs, but it is. And proving it would require some more sophisticated number theory and algebra in order to prove that this is indeed true for all cases. But we could take it for granted this is a property of logarithms that will always work. Let's use it in an example. What if we had the equation log base 2 of x to the third is equal to 12? Well, because this is a property of logs, it means that this third power of what I'm taking the log of can be moved in front and multiply the log. In other words, I could put the 3 as a coefficient multiplying log base 2 of now this remaining x. And that's helpful because undoing this 3 is simple. I divide both sides by 3, and it cancels out on this side, leaving log base 2 of x. And I divide the right side by 3, 12 divided by 3 is 4. I have one more step to get x by itself. I undo a log base 2 with a power base 2, leaving x by itself, and on the right side, 2 to the 4th is 2, 4, 8, 16. Solving this equation was made much easier by using this property of logarithms, which always works.